Welcome. Thanks for your interest in our software. I'm Marvin and I will give you a quick introduction about what is the advantage of low-code engineering and why can you as an Altair user already benefit significantly from it. I guess you have been using Altair software for a while now, but have you ever asked yourself how could I automate this task instead of doing it manually over and over again? If yes, then stay tuned. Our software is a low-code engineering platform that serves as universal language for the engineer. Think of it as a platform where you digitalize your engineering know-how, where you interconnect tools and automate your engineering processes to speed up your development. So let's take a closer look at the software. On the left side we have the canvas, our low-code workspace, and on the right side we have the viewer. Features in the software are available as components. A component has inputs on the left side, then calculations are performed and the results are output on the right. So we have built a small CAD workflow here, creating a simple CAD body that is fully parametric. We can see the changes in real time. At this point, we already have the first interaction with other Altair software, HyperMesh. The connector sends the input geometry and all supplied parameters to HyperMesh, which starts in the background, computes the mesh, and the resulting meshes are routed back. And just like that, you have a workflow that meshes a CAD geometry. Super simple, super good. Now we want to run an analysis on this part. The pre-processing is done with internal components and covers similar steps as you are already used to from HyperMesh. Then it will be solved connecting to the Optistruct solver. So what is the advantage of the low-code approach? Just like that, we have created a workflow that takes the geometry, meshes it, does all the necessary pre-processing and performs an FE analysis. What is so special about the workflow we just created? Well, it works for many similar development tasks. Let's just exchange the part. Instead of this beam, we take another one. Now we take a bigger one with a much more complicated cross-section. We just switch the input to the other geometry, wait a little and voila! We have simulated another part doing nothing more than changing the input. Instead of having again click all the surfaces or nodes for load application and so on, we just switch one cable. So what can we take away? The low-code approach helps you to automate your manual, repetitive engineering and simulation tasks, and our software makes it intuitive and easy to do so. Now you may be asking yourself how these advantages can be used in an everyday life of an engineer. One of the things that are slowing down an engineer's work is switching often from one tool to the next for different engineering tasks, for example between CAD and FEM. What are we doing is connecting all of these worlds and make it easy for you to connect yours wherever in the product development process your work might be. So let's get a brief understanding on how the low-code approach works on a real use case. This is the product development process of a steering knuckle in a car's wheel assembly. If we look at it from an overview perspective, it looks quite similar to our previous processing setup for the beam, only a bit more elaborated. In the beginning of this workflow, we import a parasolid NURBS geometry. In this geometry import, we have attributes assigned by the designer in order to connect CAD and FEM and specify where to apply our boundary conditions. We also get a specification sheet as an Excel file where we can find all material data, the loads and the target criteria. We import all of this data and cast it to a low-code workflow so we can use it later. Now we have everything we need, so let's get started with a method we call generative engineering. But hey, similar to the beam model, this workflow only features the process steps until the FEM analysis. However, we have not yet seen how we can do the topology optimization. So let me introduce you to another advantage of low-code: recycling. Luckily, a colleague has already set up a workflow for a topology optimization in another project. Sharing knowledge and workflow templates increases the efficiency of workflow definition immensely. Let's check this out. We can select the process steps that we need, copy them and go back to the workflow we were just creating. Here we paste it on the canvas and start connecting the inputs that we need. Of course, some things need to be changed. The part we are recycling from is a casting part and we can adapt some design variables to make it work also for AM. We are now ready to run the topology optimization. With a structural result, we can perform the automatic reconstruction, which takes only around a minute to create a solid CAD part with nicely connected non-design spaces. So let's sum it up. Low-code can be used to connect different engineering tools. Engineering knowledge is stored, and for the new project, you don't start from a blank sheet, but can simply recycle existing projects. So now you probably ask yourself, how do you cope with design changes or different input geometries? As this is a long workflow, the first thing I would do after creation is to simplify it. You can define individual process steps as functions and condense the workflow into logical steps. So you will get this nice overview. The best thing here is, as we already learned, you can reuse the functions in your next project or share them with your colleagues. So how do we cope with design changes? The algorithms in our workflows are general and robust, so that you can reuse them easily for similar parts. Let's say we have a different steering knuckle. We take the new input we got from our designer and we change the wire just as we did for the simple beam. You can see the whole process running, step after step after step. What before took you multiple hours, days or even weeks of manual rework, now it merely takes minutes or a bit longer than the simulation itself. Automating different tools in one workflow is great. And in terms of tool integration, we will offer you a lot more. We define our software as the first open low-code engineering platform. The low-code part should be clear by now. But what does open platform mean here? Our goal is to allow you as an engineer to glue together all the tools you normally use and automate them. For example, in the Altair Partner Alliance, you have access to the tool called Amphyon. That software simulates the laser beam melting process and allows you to calculate the predeformed part ready for manufacturing. Amphyon is usually a standalone tool, but now you are able to integrate it into your whole product development process. As we did before to recycle the workflow, we can just connect Amphyon, here already created as a function, to our steering knuckle workflow. The connection to external tools such as Amphyon will make your end-to-end development process complete. Let's sum up the advantages. You will add a new level of automation to HyperWorks, you seamlessly combine CAD and FEM, you can reuse your work to speed up the development, and you can connect your tools in one software environment. So how to get started? When you download the software, you will get an email with the login data for our portal. The best way to get started is our First Steps course with video tutorials and software examples. You will also find many other workflow templates and tutorials to learn and recycle. And if you don't find one specific tool, no worries. The open platform stands for an open API. So you have all the freedom to extend your tools, implement your own scripts and run them. Or even create your own components using our extensive software development kit. Find out more about all details in our user and developer documentation. In case you need support, don't hesitate to send us a ticket or directly schedule a meeting with us. So let's get started. We'll be happy to see you soon.